Hello everyone, welcome to my channel. So in this video, we will continue our topics in probability. In this video, I want to talk about two important terminology in probability. They are mean and variance. And here we want to focus on discrete random variable. So if you don't know what is discrete random variable, please look at my previous videos. I already give the definition and the examples in that video. So here for the mean of a discrete random variable. So let me first talk about what's the definition. So the mean of a discrete random variable, we also call this as expected value of a discrete random variable. So if we denote this random variable by capital letter X, then this mean actually is a weighted average with respect to the probabilities. And we can denote this by mu or by the capital E parenthesis X parenthesis. So here for this Greek letter, the name of this one is pronouncing as mu. Okay, so this is what's the meaning for mean of the discrete probability. So here this a small f, this is our PMF. So this is our probability mass function. So if you don't know what is this, so you should also look at my video about the probability mass function and probability distribution. So by compute this weighted average, we can get the mean of a random variable. And then the other terminology is variance. So variance of a discrete random variable capital X is a method to describe the spread of the values. So generally we denote this by sigma square. So here we call this Greek letter as sigma. And actually the definition of our sigma, we can also denote this by capital V as a short for variance. And the definition of this variance is also related to the mean or expected value. So this is an expected value of X, which is our random variable, minus the mu, which is our mean, and take square. So you can think this one, actually this, if you want to write this is, we compute this subtraction first, take square of them, and then compute the expected value of this combination. So in fact, for this equation, like compute subscribe and square and then expect, we can also compute this by two other methods. So let me write this as a remark. So this is, we can have two more formula for this definition. So this is a formula for this definition. So that means here, compare with to compute the previous expectation, or in other words, to compute this weighted average of our x minus mu square fx, we can compute this by two parts. So the first part here, this is a sum of weighted weighted average of x squared. And the second term, this is just compute the mean mu of x and then take the square. So we can use these two methods to compute our variance. So maybe some of you will ask why we have this equation. So actually this is by some computation. So let me give a short explanation of this. So if we look at the definition of our variance, so here I denote this by sigma square. So by the definition, this is take the weighted average of compare like x minus mu square. So after we plug in this definition, we can have this first step. And then for the second step, we can take this square, so it means square of x minus mu means x minus mu parentheses times x minus mu. So that means here we will get this equation here in the parentheses. And then we can use the distribution of multiplication. So we will have three terms. So the first term is about x squared this times the PMF. The second term is we can move 2 mu out from this summation because they are nothing about related to x. So then inside this summation there is x times PMF. And the last term is plus mu squared times the sum of PMF. Okay, so then for this one, what we can have is we can use the property of our PMF or about this fx. So by the property of fx, we know this term actually is equal 1. Now, because the sum of the PMF for at the all possible value of our random variable should equal 1. So that means here this equation, the last term will become mu squared times 1. And also for this equation, if we look at the second term, so this summation, this actually is our definition of a mu, right? This is how we can compute expected value or mean. So that means after we have these two, one from the rule of PMF, one from the definition of a mean, we can rewrite this equation to this equation. So now what we have here, we have this is a summation of x squared, or say the weighted average of x squared minus 2 mu squared and plus 2 mu squared. So in other words, the second and third term, this can become negative mu squared, right? So by this one, we will have our original equation will become sum of x squared times PMF and minus mu squared. So if now you compare this equation to our previous remark, you will find they are exactly the same. Right, they are exactly the same. So this is how we can have this remark here. Okay, so this is our definition for the variance. But here actually for the probability and statistics, we also have a important terminology related to our variance. So here, generally we call this is a standard variance. So standard variance of this one, this is actually defined by the square root of our variance. So generally we call this the standard deviation. So the standard deviation is like this. So here, because for the variance, we have two methods to denote this. So here, although we have two equations, but the meaning of this is the same. That all means our standard deviation is the square root of our variance. Okay, so now we already talked about all of these three important terminology of our discrete random variable. So let me give a short example of this question. So let us look at this question. So in this question, what we give us a random variable and a PMF. So here we assume this random variable is the change of one stock price within 1 day. And then here they give us a table. So this table it tells us what's the PMF of this random variable at each of the possible value. So here, in fact, in this question, in this table, they already tell us all of the possible values of this random variable. So if you want to check if my statement is correct or not, you can just sum up all of this PMF here, right? And then if this one is equal 1, then that means here we already list all of the possible value of our random variable x here. So here I just skip this part because I designed this question and I can tell you that actually it's correct. And in this question, they ask us to compute the mean, the variance, and the standard deviation. So to compute this, what we need to do is we just use our formula or say the definition of these three terminology. So for the first one, we need to compute the weighted average of our random variable. So in other words, we will times all of the possible value of this random variable with its corresponding PMF. So here this is, the first one is -2 times 0.1, and then the second is -1 times 0.05. So then the next thing is you just use your calculator to compute this answer. So here I just directly give you the answer. The answer is 0.61. So this is how we can compute the mean of this random variable. And then similarly, we can use the same way to compute the variance. So the variance, actually, we have two ways to denote this. And here I just choose the sigma square because in the question they use sigma square. So to compute this one, what we need to do is we need to compute the summation of over our x with x minus our mean, the mu. Take a square and then times with our corresponding PMF. So this one will also plug in all of the possible value here for our x. So the first one is -2 minus our mean. So mean is 0.61. Take square and times the corresponding PMF. So here is a 0.1. And we do this for all of the following possible values. So then after we have this, the next is you just use your calculator to compute this. So the answer of this is 1.2579. So this is what's the meaning for, what's the answer for our variance. And then for the standard deviation, this is just take the square root of our variance, right? So here we can plug in our answer from the previous part. So that means we take the square root of 1.2579. And after you use your calculator, you will find this answer is about 1.12. Okay, so this is my explanation of the definition for mean, variance, and standard deviation. And I also have one example about how we compute this. So in our next lecture, we will talk a little more about how to compute. Here I have still one more thing I want to talk about. I want to talk about a little more about the property of our expected values. So here, I want to talk about how to compute the mean of a function of a discrete random variable. So assume here we have x is a discrete random variable with a PMF function denoted by fx. And here x is a function of our random variable x. Then the mean of the expected value of the function h of our x is equal what? Is equal the summation of our hx times the fx. So in other words, this means here to compute the expected value of hx, this is to compute the weighted average of our h function, and here we still take the same PMF as f. And based on this definition of the property of our mean, so we can have the rule of our mean and variance. Let's assume a and b are two constant numbers. Then the mean of our ax plus b will become the a times the mean of x plus b. Okay, and then for the variance will ax plus b will become a square times the variance of x. So here, actually, as this is what we have, we can have this property by the mean of a function of discrete random variable and the definition of our mean of the random variable. So here I skip the explanation of how to get this two equation. But if you're interested in this, please leave a comment under this video, and maybe I will upload a new extra video to explain this. So thank you for watching this video. Please subscribe this channel, and in next video I will start to talk about some important discrete distributions. So hopefully you will look at my next video.